Here I've got a Hewlett-Packard 432B power meter, and it has a display, but when I put the input bolometer on it, nothing in the display changes, even when I add power to it. So this, you've got the controls change from microwatts up to milliwatts, and that seems to be the only thing that seems to change anything. The calibration factor, that doesn't change anything. You just put that on when you plug in a new power head. You set it to the number that it says on the power head, and also the mount resistance is written on the power head too. So you plug the power head into here, and it would make a difference. You'd see something happening on the display, but this display seems to be frozen. So I'm going to look into what's causing that, and I'll repair this meter and I'll restore it too. It's kind of dirty. It's got some tape on it, but other than that, it's in pretty good condition. One good thing is I have a 432A power meter, which works, and except for the digital display, they have the same front, and they have the same circuit boards. The only thing that's different is there's on the 432B, they have the extra winding on the transformer that supplies power for the display. So everything in this, the two main circuit boards are the same. So I can isolate by substitution and find out which is the bad board in the 432B I have. I'm going to start with this board here. I'm going to take it out of the meter I know works. And to get that out, there's a little plastic screw down there that you have to screw out, and then the board will lift out of the socket, out of the edge connector there. Here I've got the 432A, and I'll remove the plastic screw and switch the boards and see what happens. The boards are very, very tight and hard to work down, but that's typical of HP's extreme precision. The stuff they made in the 70s was their best. Changing that board made no difference. It's still stuck on 1200 or 12. So we'll try the other board. Now we're going to take the other board out, see if that makes any difference. Yeah, it's a tight fit, so I'll need to get that out somehow. The board's in really tight, and when I try and take it out, it's pushing against these components here. I don't want to do any damage, so I'm going to have to move this part back a bit to get it out of the way. Two screws on either side. With those two screws out, that part came out of the way and I was able to get the board out, no problem. Replacing the circuit board didn't do any good. It didn't change anything on the front display. We're still getting 1200. And I even, just for good measure, I put in the original power head, and that didn't make any difference either. It should go to 0 when I hit find 0. Something should change, but it doesn't. So there's obviously a problem in the digital section of the meter, so we're going to have to go there next. The 400 series of meters were great in that they were so easy to take apart. Everything was on two rails, well, I guess 4 rails, and there was just screws holding everything together, and you could just take them apart, and all the sub-assemblies would come apart, and it was easy to substitute if you needed. It was just a matter of removing a particular module and then put another one in. The display assembly is just held in by 2 edge connector boards, which will come out with those screws being removed. and then it can be opened up for examination and troubleshooting. Here's the Nixie tube assembly, and all removed, and there are the Nixie tubes. Next thing, I'll have to take this whole board assembly out to start troubleshooting it. Here we have the digital section of the meter. It's got the display unit in the front with the Nixie tubes, with some components behind the Nixie tubes. Then you've got an upper and lower board, and by what I can see here, you got 7490 TTL chips, and some others are probably proprietary chips. What we do know is that the driver chips for the Nixie tubes, they're okay. They seem to be displaying. We can assume that they are not the problem. And we can hope that maybe the problem is just a bad capacitor or a bad transistor. What I'm trying to figure out right now is how these chips come apart, how these boards come apart. I can see they're, it looks like some kind of a connector, and I think I can get them apart. This solder tab here just needs to be removed, and then they'll come apart and I can access the boards. So I was right, it was just that little solder tab needed to be removed there, and the boards come apart. So we got, I don't know if that's a proprietary chip, 7352, and let's see that other one. That is, let me make it out. There we are. 7306 SP3220B. I'm not too sure about those. You can look them up. It might be specific it might be HP, very specific, application specific chips that only HP sold. So maybe I'm out of luck if one of those is gone. But there's a good chance it's just one of the discrete transistors or a capacitor. And here's the lower board. As I said, there were some 7490s in there under those. And there's batteries? What those are. That electrolytic is definitely going to be replaced. It was from 1971. So 53 years old, electrolytics tend to go. There's 3 7490s. Those you can still get. And the one underneath there, I can't make it out. 6315. That might be the driver chip. Those might be the driver chips for the Nixie tubes, and those are probably okay. I think those are pretty tough. They're called Mostech, I think. It's a company that made those driver chips. So I'm going to start troubleshooting, checking all the transistors on the first board on the left. And then as I go down, I'm going to have to separate these two, pull out the Nixie tubes, and check those transistors that are down behind the Nixie tubes. As I said, that electrolytic's going to have to be replaced. And these here, I suspect they're electrolytics. I'm going to have to check them out on the schematic diagram. Here are the 3 boards separated. The last one, as I said, these 2 devices here, I don't know what they are. They look like capacitors, so I'll assume they're capacitors. but they've got polarity markings on them, but I can't see anything listed in the parts list for them, so I'm just going to have to check them as capacitors. But as I said, that little electrolytic there will have to go. It's over 50 years old, so that's the first suspect of a faulty part. Next, I will check transistors. They go fairly often, but capacitor's the number one. Diodes I'll check, but they rarely go too. And the last one I will suspect, last component I will suspect is the chips and capacitor, the small capacitors, the ceramic capacitors. Ceramic capacitors rarely go. So, I've got some work cut out for me here. I took one of the white devices out that I suspected was an electrolytic capacitor. And yes, it definitely is an electrolytic capacitor. And I had to measure it with a special device to get the ESR. So I'll show that in the next segment. To measure the one that's still in circuit, I'm going to have to use this device here. It's a ESR meter. And it has, it's designed for working with circuit boards in small spaces. So it's got a special type of Pomona clincher there. So I'm going to go in underneath and measure what the ESR of that capacitor is. First, I went back to the old meter that I previously used, and I measured the 2 microfarad electrolytic, which I suspected probably had a high ESR. And this is a perfect example of when you put a meter on an electrolytic and it says approximately the right capacitance, but the ESR is 38.4 ohms. Way out of it's just had it. It's very bad. Won't work properly at all. It should be down in the small ohms range, like one or 2 ohms at most. So that capacitor is definitely bad. I preferred not taking the second electrolytic out of the circuit, so I'm using this device here to measure it. It's got some nice little Pomona clincher leads that I can stick in and touch both leads at the same time in circuit. And it measures the ESR is 0.5. which is very low. So that is another capacitor that is okay. So we're just going to replace the 2 microfarad capacitor. I just fitted the 3 boards together to see if I could fit the capacitor that I was proposing to put in there, see if it would fit inside there, and I believe it will, no problem. It's got lots of overhead room. The capacitor that I'm going to replace the electrolytic with is approximately 2 microfarad 250 volt non-polarized capacitor. So here I have the white capacitor taken out and I'm testing it for ESR, and it's very low, it's 0.5. These 2 capacitors have crept up in microfarads a bit, but the ESRs are really low, so I'm going to leave them in. The only one I'm going to replace is the smaller electrolytic capacitor, the 2 microfarad. It has a very high ESR, so I'll replace it and put this white one back in, and we'll see what that does to the problem. We'll stick the boards together again and hook it up to the meter and see what happens. I took one of the white devices out that I suspected was an electrolytic capacitor, and yes, it definitely is an electrolytic capacitor. And I had to measure it with a special device to get the ESR, so I'll show that in the next segment. To measure the one that's still in circuit, I'm going to have to use this device here. It's a ESR meter, and it has it's designed for working with circuit boards in small spaces. So it's got a special type of Pomona clincher there. So I'm going to go in underneath and measure what the ESR of that capacitor is. First, I went back to the old meter that I previously used, and I measured the 2 microfarad electrolytic, which I suspected probably had a high ESR. And this is a perfect example of when you put a meter on an electrolytic and it says approximately the right capacitance, but the ESR is 38.4 ohms. Way out of it's just had it. It's very bad. Won't work properly at all. It should be down in the small ohms range, like 1 or 2 ohms at most. So that capacitor is definitely bad. I preferred not taking the second electrolytic out of the circuit, so I'm using this device here to measure it. It's got some nice little Pomona clincher leads that I can stick in and touch both leads at the same time in circuit. And it measures the ESR is 0.5, which is very low. So that is another capacitor that is okay. So we're just going to replace the 2 microfarad capacitor. I just fitted the 3 boards together to see if I could fit the capacitor that I was proposing to put in there, see if it would fit inside there, and I believe it will, no problem. It's got lots of overhead room. The capacitor that I'm going to replace the electrolytic with is approximately 2 microfarad 250 volt non-polarized capacitor. So here I have the white capacitor taken out and I'm testing it for ESR, and it's very low, it's 0.5. These 2 capacitors have crept up in microfarads a bit, but the ESRs are really low, so I'm going to leave them in. The only one I'm going to replace is the smaller electrolytic capacitor, the 2 microfarad. It has a very high ESR, so I'll replace it and put this white one back in, and we'll see what that does to the problem. We'll stick the boards together again and hook it up to the meter and see what happens. I found this 160 volt 4.7 microfarad electrolytic capacitor, and I found if a circuit is designed for electrolytics, it's best to stick with electrolytics. I was considering that plastic capacitor because I couldn't find any high voltage, low capacitance electrolytics, but I found this one, and I'll check it out with the ESR meter and see what it comes to. There I've got the capacitor hooked up to the ESR meter, and we have just 1 ohm ESR, so that's very good for that value of capacitor. So I'll put that in the circuit. So I took out a couple of components that I thought might be faulty, and this one was the transistor here, and it turns out to be good. Sometimes when you check things with an ohm meter like transistors, they come out to be good when you actually remove them. So I can't find any faulty components other than that capacitor. So I think I am going to put it back in and see how it acts with the new capacitor. I've put everything back together again, except haven't put the display back in the case. But here it's hooked up roughly, but the display has gone to 0 now. But it doesn't seem to be responding to changing into the controls. It does change decimal place, but when I put the actual bolometer head back in, it doesn't respond. So I think what I'm going to do now is just put this aside. I've gone far enough, spent enough time with this. For now, I'll just have it as a parts unit. What I've done is I acquired another one, another 432B, and it has a good display, seems to respond, but it won't 0. So what I'm going to do is take a couple of boards out of this one and see if I can get the other one to 0. The other one is in better condition than this. So I'm going to use that, try and fix that, and use that as my working power meter. This one I'll put back together again and just use it for parts as needed. So this power meter refused to 0. So what I did was I first swapped that board from the other one, and it wouldn't cause it to go back to 0. So I swapped that board right there, and that made all the difference. So now I have a meter that actually zeros. I've got the bolometer head hooked up, and there it's measuring milliwatts. Now I hit that, find 0, and it puts it to 0. 0's the meter. So now I've got a working meter. The reason that I'm not going to proceed anymore at trying to fix the display is because I think it is a problem in the TTL circuitry. And as I said earlier in the video, there are a bunch of proprietary chips in there that are unobtainable now, 50 years after the unit was made. So the only way to fix these, I don't have a proper schematic for it. The only information I can get is I downloaded a manual, which is for the 432B that has a digital display, all right, but it's an LED display, not the display that is for the Nixie tubes. So I will just keep it as a parts unit, because I've got a couple of these meters, the 432A and 432B, and considering their age, you never know when they're going to go. So I'm just going to leave it at that. And in the next video, I'm going to make an attenuator so I can use this for measuring much higher powers. This unit will only go up to 10 milliwatts, and that's kind of useless for amateur radio. I'd like it to be, actually I'd like to measure up to 1,000 watts. So I think I will make a 10,000 times attenuator, which will make this 1,000 watts full scale. 10 milliwatts will be the equivalent of 1,000 watts. So I'm going to work on that next. So I'm just going to see how accurate this power meter is. So it's it is at 1 gigahertz, and it's minus 2.8 dBm. Now let's see what it is in microwatts. First of all, I'll 0, then hit enter. 0.433 milliwatts, so 432 microwatts. That's what it says, and it should be 525. So it's about 100 microwatts off. Now, the other meter is not necessarily really accurate in its output, but that gives me a general idea that it's a little off. I'll try this bolometer with the other 432A. So I've set up the 432A with the same power going into it, with the same bolometer, and the signal generator is putting out minus 2.8 dBm at 1 gigahertz. It's set at 1 milliwatt full scale. And fortunately, this meter reads both in microwatts, in watts, milliwatts, microwatts, and dBm. So what we have here is 1 milliwatt full scale, so it's measuring about 415 microwatts. And that is down from 0 dBm. That'll be minus 1, 2, minus 3, minus 3.67, minus 3.7. So that's a fair amount out. It should be measuring 525 microwatts. But one thing it's doing is it's exactly the same as the digital meter. So I know the digital meter is not out, it's accurate. It's the bolometer that needs calibrating. I realized I made a mistake here. I'd forgotten to take into consideration the calibration factor, which adjusts it to the proper calibration when you're changing bolometer heads. So there's a little chart on the side there, and that will allow you to put the setting of the calibration factor to what it should be at that particular frequency. So I'm putting out plus 2.7 dBm, and that is approximately, it's a little higher than 1.73. It's something like 1.86 or something, but it's close enough. There's lots of variables, like cable losses and things like that. So I think that's close enough. I'm not going to worry about it too much.